Let's understand Python's regular expressions or Python regex through this video. A regular expression in Python provides a powerful way to search, match and manipulate strings based on a defined pattern. It can be used to detect the presence or absence of a text. It can be used to split a pattern into one or more subpatterns. And to do all this, there is a built-in module RE that's used for regular expressions. And why do we have to use regular expressions? I have listed out a few purposes, and it plays such an important role in doing coding using regular expressions. And to understand the regex in Python, this is a table showing all the possible characters that can be used in a regular expression. So the caret symbol refers to the start of the string, the dollar refers to the end of the string, the dot will indicate any character other than the new line character, and these will come under the category called sets. And if you put within square brackets a series of characters, it means any one of those characters, and if those characters are preceded by a caret symbol, it means not one of these characters, and if there's a hyphen between two characters that are given, it means range. So any character in that range, small a to small z, and this will mean any uppercase alphabet or any digit from 0 to 9. Now these are called quantifiers. The asterisk will mean 0 or more number of occurrences of the letter or character. The plus will indicate one or more occurrence. A question mark will indicate exactly 0 or 1 occurrence. Within curly brackets, when you put n, it refers to exactly n times. So if you have a slash d will refer to digits 0 to 9, and following the slash d in curly brackets, if you mention a 3, it means exactly 3 digits. So something like 1 2 3 6 9 0, things like that. And if there is a n comma, it means minimum n and maximum can be any number of times. If you've mentioned both n and m, it means the number of occurrences of the letter prior to this is n to m times. Now these are called predefined classes. The backslash d referring to a 0 to 9, a backslash uppercase d refers to not a digit, a slash w lowercase will refer to any word character, a slash uppercase w refers to not a word character, a slash lowercase s refers to all the white spaces, and a slash uppercase s refers to non-white spaces. And then we have certain other patterns, symbols which are shown here, and if the dot itself happens to be a part of an given string, let's say in email address we want to look for a .com, so there we do not want the dot to be treated as any character, so we want the dot itself to be part of the string, so we mention such things using a backslash, the escape sequence or the backslash character. And then the slash b refers to a boundary. So like that's shown here, a slash b cat slash b will look exactly for a cat, but not for a cat that is part of a word, say scatter. And these are the special sequences which have been listed out, what you saw in the previous slide. So making use of all these, let's try and do some samples for understanding regex even better. And we'll be covering these common functions under the RE module: the match, the search, find all, find iter, and sub, and the split. So the match, as mentioned here, will only search for a string at the start of the string, whereas search will search anywhere in the string. Find all will return all the possible matches, and it will return it in the form of a list. Find iter will return an iterator of the matching objects. A sub is to be understood as substitute. So this is to replace a given character with a different set of character in the given text S. And then split is to split a given text based on a pattern that is provided. So let's look at examples for all of this. I have assigned a string to a variable st which reads big bag black wolf jumps over the lazy wolf, but there is no wolf pack here to see. So this is the string that we are going to be working with. So like I said, we need to import the RE module. Let's try and see what the search function does. So the search function, and all of these functions, the first argument is your regex pattern. Now we'll first look at the exact match, where I'm not going to provide any expression. I'm going to look for exact match of the word, let's say wolf. And where am I going to search for this? In the given string st. Now for you to understand the difference between search and match, what we saw in the slide, the search is going to search anywhere in the given string, whereas the match is going to search exactly in the beginning of the given string. And if there is a match, the match will return, both the search and the match will return something called the match object. But if there is no match, then it will return a none. So I'm going to execute this. I've pressed the F5. Okay, my bad. The import was wrongly spelled. So if you notice, the first output is the result of search. So in search, I have wolf, and this match object has got certain methods. Like for instance, I'll just show you. We can have the result of search stored in a variable, say m, and then if you try to print m.group, the method group will return exactly the match string, and then there is another method m.span. This lets you know from which subscript to which subscript that particular string was found. This is obviously going to return the first occurrence. So the wolf occurred here, the first wolf, the word wolf occurred here. So if you look at the subscript of wolf, where it first occurred, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is where it first occurred. And you also have a method called start. So this m.start will give you the beginning index where that word was located, and you have obviously m.end, which will let you know the ending subscript. Now in the output that we saw, this returned a none, because beginning of my string I do not have a wolf, therefore returned a none. I'm going to execute this. So m.group, the result is the word that was found, and the span gives you from which subscript to which subscript that word was located. So from 10, subscript 10, 11, 12, 13, including 13, the subscript of the last, just like a range. It will add, include one more number until in that span the word wolf was found. So that's the start and that's the end subscripts. And the none was the result of match, because wolf is not found in the beginning of the string. So match will check for the given pattern from the beginning of the string. Search will search anywhere in the string and return at the point the first occurrence of the given pattern was found. If I had wanted because this string has got several times the word wolf occurring, so if I had wanted all the occurrences of the word wolf, how many times the wolf occurred throughout the given string, I could go for the function find all. So firstly, we are only trying to see an example using exact match. So I'm looking for exact match of wolf in the given string st. So like I said, this find all is going to look for all occurrences in the given string and returns the result in the form of a list. So I'm executing. So it is shown wolf thrice because there is one wolf occurring here, a wolf occurring here, but then this wolf does not have wolf as a word. It's part of another word. Wolf pack is the word of which wolf is a part. Now we do not want wolf matching partly. We are looking for whole words wolf. Then we can make use of this escape sequence. If you can recollect from the table that we saw, there is an escape sequence for border. So if I say /b/b, it means I'm bordering the word wolf, which otherwise is to be understood wolf to occur as a single word, not as part of another word. So now when you execute, it's showing an empty list. Basically it should have shown a 2 because I do have 2 occurrences of the word wolf occurring as a single word. But why did it show an empty list? That's because now we have learnt about escape sequence characters. A slash b is going to refer to backspace. Now when you write a expression like this, Python is going to look for an exact match which starts as slash b, wolf slash b and so on. We are trying to infer that this is to be used, to be understood as the border, the sequence for referring to the border. So in cases, always it's a good practice to have your R notation to refer to it as a raw string, so that the slash b's won't be misunderstood or mistreated as a escape sequence character. So here the slash b is explicitly to refer to the border. So now when I execute, I have included the raw string indication. Now I am to execute. So now here it is shown wolf occurring only twice. The wolf as part of the word wolf pack will not be retrieved. Now we'll look at some examples using the regular expressions. I have a text here, hello world exclamation test 1 2 3. Using this, let's attempt doing a match. So re.match. Like I said, always have this raw string notation, and in quotes we'll have the regular expression written. Assume here I'm trying to look for uppercase characters where it is found one or more number of times in the given variable text. And if the match has been found, now match will return a match object, and for the match object I can display details using the methods group, span and so on, what we saw in the previous example. If the match did not return anything, then it will return a none. So I can check if there was something returned or not by using a if a. That means it returns something, not a none. If that is the case, I wanted to display the result of group and let's say result of span. Now I am to execute this. So the first occurrence H happens to be the uppercase letter. Now the plus refers to one or more times. So at the beginning of the string, match will always search for the beginning of the string. So it will it has returned subscript 0. The span is subscript 0, and it will include that one extra for the ending subscript. But supposing this H was a lowercase h, then it's not going to be returning anything, though I do have a world as a second word. So in the else part, if I say no match, I re-execute the code. Obviously it will show no match, because match will always search only at the start of the string. Further down the string, if there is a uppercase letter occurring one or more times, it will not be identified. But what if I want Python to continue searching from say a particular location? So 0 1 2 3 4 5 at this point. From 6, that's where my next uppercase letter starts. So I can have a way by which I can tell match to search from elsewhere, not from the beginning of the string. Let's see how that can be done. To do this, we need to create something called a compile object. Let's have a variable say p equal to re.compile, and in the compile I'll mention the pattern that I want. That is, it has to be a uppercase alphabet occurring one or more times. Just the pattern I'll write there and create my compile object. Using that, I'll run my match function on the given variable text, and here I'm particularly saying 0 1 2 3 4 5 6. 6 is the place where the next uppercase letter is starting. So by default, what it would have searched from the beginning subscript, I'm forcing it to start matching from a given particular subscript. So if it is found, then m is going to be, so I can have a check. If m didn't return a none, then I want the matched character to be displayed, and in what subscript span it was found. So let's rerun this code now. So the matching character was world, found in subscript 6 up till 11. So to have a match done at a different location, overriding the default beginning location, then that's possible by creating a compile object in such a syntax. So let's continue with the other functions using this regular expression. So I'm having a variable a which is going to store the result of search. So we saw the match, now we'll see the search. Again a raw string notation. I'm giving the pattern the same thing to look for a uppercase letter occurring one or more times in the given text. And if a had some value returned, then I'd want the details shown, a dot group and a dot span. I am to execute this. So the first occurrence of the uppercase letter was in the 0th subscript. So search will search anywhere in the given string, but it will only fetch the first occurrence. At the point the first occurrence was encountered, it will return back the matching object. But if I had wanted all occurrences, then we have the find all. So I'll go for a re dot find all. We'll go for the same expression. So that's a raw string, uppercase A to uppercase Z occurring one or more times in the given text. And then my find all is going to return the result in the form of a list. So wherever there was a uppercase character occurring one or more times, all those result set has been generated. Now we'll see the find all for finding only the digits that are found in the given string. So I do not want any other result. I only want what are the digits that are found in the given string. So I'll go for a re dot find all, and for getting the digits the pattern will be, that's an indicator of raw string, a /d to refer to digits. I want digits which are occurring one or many number of times in the given text. And if I try to print a, so 1 2 3, that is a digit set that is found in my given string. Probably we'll have this commented instead of re-executing them over and over again. So next we'll try and have a look at re dot substitute. My digits, supposing I give an expression like this. Now this is to be understood wherever there are digits occurring one or more number of times, you replace it with, let's say, asterisk in my given variable text. And now I am to print the result of a. So wherever there were digits, I have asked those digits to be replaced with a series of asterisk marks. That's what a sub does. And finally we'll look at the split, where probably I want to split across words. So my pattern will use a expression where there are separators for words. There is a exclamation here, after which there is a word separator, and then there is probably a space, so I'll give a space. Supposing the given character had given string had a period at the end, that also refers to end of the word. So all these, one of these symbols, so in square brackets it means one of these symbols, if they occur one or any number of times, at that point you split. And finally show the result in A. So my word has been, given string has been split wherever there was a space, where there was an exclamation, and it will always generate this empty string at the end, because after the period there was nothing, so that last empty string is also going to be shown. So this is what a split does. We look at few more examples. So now I want a phone number to be validated. A valid mobile number should have 10 digits. So let's accept the phone number in a variable ph. So I'll ask the user to enter a phone number. I need to validate this number. So I'll have a object which will have the result of re.match. My regular expression pattern is going to be, this has to have a digit occurring exactly 10 times. And in which variable am I checking for 10 digits? In ph, but ph is read as an integer. These regular expressions we saw they are something that works on strings for searching and manipulating strings. So we shall typecast ph as a str. Okay, I haven't closed the regular expression. So this phone number, if it had exactly 10 digits, then a is going to have a true value, otherwise it will have a none. So I can check if a is holding a matching value and then go on to print the message, it's a valid phone number, else print invalid phone number. So let's execute this and see. So I'm entering a phone number, say 1 2 3 4 5 6 7 8 9 10. So that's a valid phone number. In case I had entered a number lesser than 10 digits, it's going to display invalid phone number. For the next example, assume I have a variable which is assigned to a string, and in the string there are lots of hashtags. Just the hashtags I need to retrieve. So I'll have a variable which will store the result of find all, and I'm going to give an expression where the word has to start with a hash followed by a word having one or more characters, and that is in my variable des. And if I print the variable a, that has to retrieve just the hashtags. So all the hashtags has been retrieved. So it has to start with a hash followed by any word character occurring one or more times. In the next example, we assume we have a text which says X was born on this day and Y was born on another day. We want all the date formats extracted. So let me have a variable which will store the result of find all, and my regular expression is going to be I need to have digits which occurs exactly twice to represent the day, followed by a hyphen, digits which occurs twice to represent the month, followed by a hyphen, and digits which occurs exactly 4 times. So wherever I have such a format, that has to be retrieved from T and stored in a A. So let's print A. Now I am to execute this. So the date formats have been obtained using the regular expression which I have shown here. In this example, there is a string which contains numbers which represents the bus route and then the time and also 2 pin codes. So there are numbers in different forms. I want to extract just the valid pin codes, which are these 2 values. So let me have a variable which will store the result of find all, and my expression is going to be, it has to be, because all valid pin codes will start from a non-zero value. So I'm specifically saying the first digit has to be anything from 1 to 9, and the second digit can be 1 to 9, and the second digit can be anything from 0 to 9, but pin codes, postal index numbers, are all 6-digit numbers. Because the first number we have said has to be any number 1 to 9, the rest can be only 5 different numbers, 5 numbers, anything from 0 to 9. So I'll say this has to occur 5 times. So the first digit has validated to be exactly 1 to 9, and the rest of the 5 digits can be anything from 0 to 9, and that is to be checked in the given string T, and we will print the result of A. I am to execute this. So though there were other numerical values, exactly the pin codes only have been retrieved. In this example, we'll try to extract words that end with the ing. Now eating, singing, playing should be the words. There is a ping pong where there is ing as part of the word, that should not be retrieved. So what should be the pattern for this? Let's have an object variable a to store the result of find all, and my expression is going to be I want a border, that is it has to be a whole word, not part of another word. The word should have characters, can have characters, one or many, but should finally end with the ing, and then I'm closing the border. So I'm providing the border to say it has to be a whole word but not part of another word, and it has to have word characters occurring one or any number of times but finally ending with the ing. This is to be checked in the variable t, and that I'll print. I am to execute. So only eating, singing, playing has been retrieved. Ping pong has not been retrieved. As one last example, let's see how to split a sentence into words. So I have a sentence, today is a bright, sunny day, exclamation. Isn't it awesome? Question mark. So I only want the words extracted. So I could have done the procedure that I showed earlier. So I'll say a split, having my pattern to be anything that's got a comma or a space or an exclamation or a question mark occurring one or more times from the given variable t, split against all those given characters and extract the remaining as words. So if I execute this, so I have obtained all the words without the characters. Now instead of having such a big pattern written, I could have also done this as re.split, the pattern being, we have seen this uppercase W which refers to non-word characters, which will be anything other than alphanumeric. So this occurring one or more times in the given variable t, and then I get to print the b. So it's going to retrieve again the words separated at the parts where there are punctuators or there is a space. So hope this small demonstration has given you a small insight into regular expressions in Python.